Today we're starting the quadratic functions unit, and the very first learning target is to decide if a set of data, either like as a graph or as a table, is a quadratic function or not, if it's something else like a linear function. So to tell with the graph, you just need to look at the graph and decide, is the graph a line? If it looks like that, then it's linear. A line is linear. If it looks like a parabola, which is kind of like a U, or it could be an upside down U, that's called a parabola. Just like the graph of a linear function we call a line, the graph of a quadratic function we call a parabola, and that means it's quadratic. For a table, we tell the difference between a linear and a quadratic function depending on the change. If you remember, for a linear function, the change is constant. So for example, it goes, you add 8, add 8, add 8, add 8. If that first change is constant like that, if you're adding 8 the whole way down, that means that that is a linear function. So you can write linear. And if we wanted to write a function for that linear function, we notice that we have the y-intercept. We have our slope is 8 over 1, or just 8. So the function would be 8x plus 18. That's what we learned 2 units ago in the linear function unit. Now let's take a look at this one. You're going up 1, up 1, up 1, up 1 over on the left side in the x column. Now here, to get from 192 to 132, you're going down 60. To get from 132 to 80, you're going down 52. To get from 80 to 36, you're going down 44. And to get from 36 to 0, you're going down 36. So we know right here that this function is not linear because it does not have a constant adding and subtracting change. It's subtracting 60 and then 52 and then 44 and then 36. So it's not constant. However, if we take the second change, that's the change of the change. So now we do the same thing that we did here to get these numbers, but now we do them with these numbers. So to get from negative 60 to negative 52 on the number line, you move 8 to the right. So that's up, adding 8. To get from negative 52 to negative 44, you would add 8. And to get from negative 44 to negative 36, you would add 8. So because that second change is constant, so this is the first change, we'll call it. This is the second change. It's the change of the change. So the second change, because it's constant the whole way down, this is a quadratic function. And we don't know how to write functions that are quadratic yet. We're going to start learning that in learning target 4. So until then, we're just going to write quadratic. Now let's try the next one. It's going up 1 over here the whole way. To get from 30 to 72, you add 44. To get from 72 to 26, you would add, so 28 plus 26, that's adding 54. To get from 126 to 192, you would add 64. I believe. If you're not sure, because I always have a hard time doing math in my head when it comes to numbers like this, I can always take the one below minus the one above, and it's 66. So that's adding 66. I'll double check this one. 126 minus 72. Whoops. 126 minus 72. 54. And then 72 minus 30. 42. Whoops. So we have 42, 54, 66. And then this one is 78. So to get from 30 to 72, you would add 42, 72 to 126, you add 54, 126 to 192, you add 66, and 192 to 270, you add 78. So now we know it's not linear, so now we'll take the second change to see if it's quadratic. To get from 42 to 54, you add 12. 54 to 66, you add 12. 66 to 78, add 12. So we know that it's quadratic because our second change is constant the whole way down. Now we'll do the last one, and to get from -8 to -15, well, first over here it's going up 1 each time. Then to get from -8 to -15 on the number line, you would subtract 7. To get from -15 to -22, you would subtract 7. To get from there to there, you subtract 7 and subtract 7. So because the first change is constant, I know that this function is linear, and I can write a function using slope-intercept form because I have the y-intercept. So I'm going to write f of x equals -7 over 1, which is just -7. That's my slope, mx, and then my y-intercept is -29. So that's how you can tell if a function is linear if the first change is constant, or quadratic if the second change is constant. And that is the first learning target.